Hello students, welcome to the e-learning platform presented by Mechanical. For last session we had studied till different types of cutting tool. For today's session we will be learning the remaining part of the first chapter, that is cutting methodology, that is different cutting methodologies, orthogonal cutting and oblique cutting. And second, let us start with method of cutting metals. Orthogonal cutting is first type of method of cutting metal. Orthogonal cutting is a type of metal cutting in which the cutting edge of wedge shape cutting tool is perpendicular to the direction of tool motion. In this, cutting edge is wider than the width of cut. As shown in the figure aside, the workpiece is fixed or in a stationary position, whereas the cutting tool is moving from upside to the downside movement. The chip is formed over the cutting tool. The cutting angle of tool makes right angle to the direction of motion. The chip flow in the direction normal to the cutting edge. In orthogonal cutting, there are only two components of force generated and can be represented in 2D coordinate. The component of force generated are cutting force and the thrust force. The tool has lesser cutting life because the shear force acting per unit area is high, which causes the increase in rate of heat developed per unit area. In this cutting method, the chip flows over the tool. Next type of method of cutting metal is oblique cutting. Oblique cutting is another type of cutting in which the cutting edge of wedge shape cutting tool makes an angle except right angle to the direction of tool motion. As shown in figure, we can see that the workpiece is again stationary or fixed and the tool is moving along the upside direction. The cutting tool makes an angular degree, some angular degree with the workpiece, and the chip is flowing again over the cutting tool but away from the cutting tool. The cutting angle of tool does not make right angle to the direction of motion. Other than right angle, it makes any angle may be oblique greater than 30 degree or 40 degree. The chip make an angle with the normal to the cutting edge. In oblique cutting, there is addition of one more force, so that this system is not represented on 2D coordinate. It is represented on 3D coordinate and also known as 3D cutting. The forces which are observed are the cutting force, the thrust force and the radial force. This tool has higher cutting life. The shear force per unit area is low, which also reduces the heat developed per unit area. The chip flows along the sideways. Let us all take a moment and recall what we have learned in the previous sessions and till now. Number one, what is or what are the different types of chips and cutting tools? Students, please, by listening to the previous session and to this session, try to write down the answer for these questions, as these questions are asked in MSBT examination in your winter or summer examinations carried out for 70 marks. Second question, what is the difference between the orthogonal and oblique cutting? Please try to write the answers for the same in your own language by listening to these sessions. Next point is single point cutting tool. As the name implies, single point cutting tool is a tool which has only one or single point used for cutting. Single point cutting tool is normally used for planning, boring, shaping or turning operations. As shown in figure, single point cutting tool is used in lathe machine which is usually made of different materials. Figure shows the single point cutting tool made up of HSS material in which only a single point is sharpened so as to perform the cutting or metal cutting process. Single point cutting tool, as name implies, one cutting point or tip is available as shown in figure. The single point cutting tool materials commonly used are high speed steel, cast alloy, cemented carbide and cemented oxide. The introduction of expensive cutting tool material has necessitated that the body of the tool must be made of less costly material with tip of material attached at the cutting point. This tip is also known as tool insert. This is made so as to reduce the cost of the cutting tool. In this, the cutting tool shown in the figure consists of a body made of different material known as tool body or shank, and the cutting insert used while performing the cutting operation. There are different shapes of inserts and can be bolted or riveted at the time of performing cutting operation. The tip or cutting insert is held in proper position mechanically or permanently soldered or braced in position. It may be pre-sharpened, that is, it may be sharpened, or it can also be sharpened using the grinding machine. Next point is geometry of single point cutting tool or nomenclature of single point cutting tool. Figure shows single point cutting tool. The first part is shank. It is the main body of the tool. Next is size, determined by the width of shank, height of shank and total overall length. Next is face. Face is nothing but the surface on which the chip impinges. Next is cutting edges, the portion of face edge that separates chip from the workpiece. Basically, there are two types of cutting edges: end cutting edge and side cutting edge. And the last is nose. The nose is the intersection of side cutting edge and end cutting edge. Next part is geometry of single point cutting tool of various angles. By the use of cutting edge and the tool body, the different angles are formed, which are described as: number 1, side cutting edge angle. The angle between the side cutting edge and side of tool shank. Number 2, end cutting edge angle. The angle between the end cutting edge and a line perpendicular to the shank of tool. Number 3, side relief angle. The angle between the portion of side flank immediately below the side cutting edge and a line perpendicular to the base of tool. It is an angle that prevents interference as the tool enters the work material. Fourth, end relief angle. The angle between the portion of end flank immediately below the end cutting edge and a line perpendicular to the base of tool. It is the angle that allows the tool to cut without rubbing on the workpiece. Fifth, back rake angle. The angle between the face of tool and line parallel with base of tool. It is the angle which measures the slope of tool from the nose towards the rear. The last is side rake angle. The angle between the face of tool and a line parallel with the base of tool. It is the angle that measures the slope of tool face from the cutting edge. Next point is tool signature. A convenient way to specify tool angles is by use of standardized abbreviated system called tool signature. The various angles are specified by a standardized abbreviation system is known as tool signature, sometimes also known as tool characters. The tool angles are taken with reference to the cutting edges and are therefore normal to the cutting edge. They are of particular importance to tool designer and machinist because these are the values that are used while designing or grinding of a single point cutting tool. Let us see one example of how tool signature is given to the single point cutting tool. The tool signature basically consists of all angles and the nose radius given as 0 7 7 7 15 15 0.8. In this, each box contains a significance. For the first box, it is the 0 stands for the back rake angle, that is 0 degrees. 7 stands for the side rake angle, that is 7 degrees. Third is end relief angle, that is 7 degrees. Fourth box stands for side relief angle, that is 7 degrees. Next is the end cutting angle, that is 15 degrees. Then 15 degrees again is side cutting angle, and the last is the nose radius, which is 0.8 mm measured in mm. Example of tool signature as shown is been asked in previous examination for MSBT question papers. Please note down how the tool signature is given, and you are expected to write the tool signature for the single point cutting tool. Next part is influence of various angles on tool design. Number 1, back rake angle. The rake angle of single point cutting tool is useful for determining the direction of chip flow across the face of tool. That is, this angle is responsible for the determination of chip flow. Second is side rake angle. Side rake angle is angle that is used to avoid rubbing action between the tool and the workpiece. Side rake angle should always be positive. Third is side cutting edge angle. Side cutting edge angle may vary from 0 to 90 degree. On increasing side cutting edge angle, the full length of cutting edge is not in contact with the workpiece when the tool enters the cut. If the side cutting edge angle is 0 degree, the full length of cutting edge is in touch with workpiece and produces initial shock. Increase in the side cutting edge angle increases the surface finish. Next is end cutting edge angle. End cutting edge angle may be varying from 4 degree to 30 degree. It is angle that prevents rubbing between the end of the tool and the workpiece. If end cutting angle is less, it will cause vibration because of excessive tool contact with the workpiece. And last is nose radius. Nose radius is provided to increase the tool, strength of tip of the tool. It is also provided so as to increase the surface finish. If the radius is more, the surface finish will be good, but due to large nose radius, there will be more contact between tool and the workpiece, which in turn will increase the friction and increase the power consumption, which again will increase the vibration and chatter of workpiece will occur. Let us see what we have seen in today's session. First is metal cutting processes, that is orthogonal cutting and oblique cutting. Second, geometry of single point cutting tool. Geometry of single point cutting tool has been explained in detail. Third, tool signature. Tool signature of single point cutting tool has also been explained. Fourth, influence of various angle on tool design. While designing of tool, how various angles are influenced is also explained. This concludes our first chapter. In the first, second and this third session, we have completed our first chapter. Thank you.